we are going to discuss about the method for the beam and frame, which is direct stiffness method. I have already discussed about the trusses about this method, which I will be given link in the description. You can see it here. So this is an introduction and other things which already I have discussed in previous video, so you can check it out. Right, so I can go directly to the example. So basically you need to remember these cases. What is case 1, case 2 and case 3? This is your general equation, and your case 1 is if you are solving and finding just a bending moment only. You can see it here, there is a text. If you are finding only bending moment, then you can use this formula. Okay, so and if you are finding shear force and bending moment both, then you can use this equation, this matrices. So this is 6 by 4 by 4, and this is 2 by 2, and this is 6 by 6. Okay, this is for also for axial shear and bending. Try. So this is for all forces when you are finding it. Okay, so basically x direction, y direction and moment in n direction. So here is our example which we are going to start. So here we can see that this is our beam, 1 hinge support, 3 roller support. So we know that it is indeterminate structure, which I have already discussed how we can find indeterminacy. We can see that at hinge we have 2 spots and roller we have 1. So 2 1 1 1, which is 5. So equilibrium condition is 3. So 5 minus 3 equal to 2. So we have 2 degree indeterminacy. So now we are going to solve it. Basically this beam have 2 parts. One have point load and the other is have you can see it's a UDL. Okay, so for point load we are using this equation and this formula, and for UDL we are using this formula. Okay, this formula in which we are saying A is the distance, what is P? P is the load, A is the distance from point A, B is the distance from point 2, and same as the W. W is the load, and L is distance, and same as we are just putting formula from this chart. Basically this chart will be given in papers exactly, and you must have this chart where you are solving these type of problems. So how you can at initially you are finding the moments, these type of moments. How you can find? You can just take values from the chart. So for point load this is your value, and from UDL you have these values. So just put, I can solve one value which is here P, A distance, B distance, and divided by L. P is 10, 5 from point A distance and 5 from point B distance. So L is total length, which is 10, so total 1. Here is same as it is from this. 2 is the overall load, and A is distance from point this, and B is distance from point this, and total overall length. So here you can find these matrices. How you can solve? You have 12.5 is at here and 12.5 from this side. So same formula, just a sign convention is changed, which we can see it here. here is two formula from MB and from C. From one game you find two moments. Okay, so here is minus 12.5, here is 12.5, same as this. This is 37.5. How it come? It come from this formula. Okay, so this is 37.5, which is come at here, and this 37.5 come at here, and this 39 is at here, and this 39 at here. So now we are just calculating net fixed end moment. How we can calculate? We can just take this forward traction moment, which is minus 12.5, as we know this, and this is the main point at where this is roller support. So roller support had two values, 12.5 and this 37.5, so we can just add them, and all this point value has come at here. This is minus 25, which I have written at here. Okay, same as this, we have C point, we can just add them, minus 39 and minus 37, which is this. Okay, so here is minus 1.5 and minus 39 is sample. So after this value we can get and come at here. So this is our loads, basically reactions and moments, how we can calculate. So we can make a chart, number 1 2 3 1 2 3, I is value 1, joint is have 2, same as it is I have value 2, joint 3, and 4 same as it is 4, 3 I value and joint is 4. So for this equation, now we have seen that this equation for case 1 we have already studied at here. This is our case 1. We are just dealing with moment, so we can discussing case 1. So case 1, we are putting just value EI by L we take common, and 4 2 2 4 we just come at here. L value is 10 for K1. K1 we know that the value of K1 is 10. Okay, so we just divide them, 4 divided by 10.4, and this equation comes same as it is for K2. K2 value is 15, 15 is the distance, this one, 10 is this, and 12 is this. So this is 12, 15 and 10. Same as this, we are just dividing in from K1 and K2 value. So now this is sum of these 3K values. How it come? This is we are just dividing 1 2 3 4 and 1 2 3 4. If we are selecting how these value come, 1 first column, first row, 1 and 1. Where is 1 and 1? 1 and 1. 1 4. Here is no 1 and 1, no 1 column, no 1 row. So here is 0.4. 2 column, 1 row. 2 mean you can see just a number. Here is have 2, 2, 1. Here is have 2 but no have 1. Here is no 2 and 1, so just get 0.2. Now 3 and 1. Here is have 3 but no have 1, so just put 0. Same as this, if we have take multiple value, for example 3 and 3, if we are calculating this one 3 and 3, so we know that 3 and 3, 3 and 3, so we can just add these both values and then put it here. He has just put these values and add them. Okay, so now this combined equation come. After that we just finding the unknown deformation, how we can calculating, just putting value, so taking K this value inverse. Okay, here is the equation, we just take inverse and all putting values get from this. This is our W 2.5 and this is this matrices. So after these two matrices we just multiply, and here is the result term 18.8 is this is equation is at here, and this equation we get it from this.